Right now, you're sitting in a chair, feeling completely still. But you're actually racing through space at 600 kilometers per second towards something. Not Earth's rotation, not Earth orbiting the Sun, not the Sun orbiting the galactic center. It's the entire Milky Way galaxy, with all 400 billion stars inside it, all planets, everything, being dragged by something. Speed, 600 kilometers per second. 2.16 million kilometers per hour. 2,000 times faster than a bullet, 1,700 times faster than sound. At this speed, Earth to Moon takes only 38 seconds, Earth to Sun only 7 hours. But here's the problem, we don't know what's dragging us. 1929, astronomer Edwin Hubble discovered the universe is expanding. All galaxies moving away from us, the farther away, the faster they recede. This is the standard model of cosmic expansion. But in the 1970s, scientists began precisely measuring the Milky Way's motion and discovered something strange. The Milky Way's velocity was much faster than cosmic expansion predicted. We're not just receding with expansion, we're also moving extra towards some direction at 600 kilometers per second. Like standing on an eastbound ship but also running north on deck, your actual motion is the combination of both velocities. The Milky Way is the same, expanding but also being pulled towards something. Late 1970s, astronomers began mapping nearby galaxy motions. They discovered all galaxies are falling in the same direction. Not just the Milky Way, Andromeda falling that way, Virgo cluster falling that way, all galaxies within 200 million light-years falling toward the same coordinates. Like leaves in a river all drifting downstream, meaning there's a waterfall downstream. 1986, astronomers determined the coordinates. Right ascension, 13 hours 20 minutes. Declination, -44 degrees. Distance, 220 million light-years. Direction, between Centaurus and Crater constellations. They named it the Great Attractor. But there's a fatal problem, that direction is directly behind the Milky Way's disk. Imagine standing at edge of a giant disk, thick dust clouds in the middle blocking your view. You want to see what's on the other side but can't see through. This is the Milky Way's zone of avoidance, 1,000 light-years thick of dust and gas blocking all observations in that direction. Visible light blocked, infrared blocked, even most X-rays absorbed. We can only use radio telescopes to barely see some blurry outlines. But we know it's there because gravity penetrates everything, not blocked by dust. By measuring nearby galaxies' velocities, scientists calculated the Great Attractor's mass, 10 to the 16th power solar masses. Written out, that's 10 quadrillion suns, equivalent to 10,000 Milky Way galaxies. This enormous thing is pulling all galaxies within 200 million light-years with irresistible gravity, including us, making us fall toward it. 1990s, radio telescope technology improved. Scientists barely penetrated the Milky Way's dust and saw outlines behind the Great Attractor. There's a huge galaxy cluster called the Norma Cluster, containing tens of thousands of galaxies. But the mass doesn't match. The Norma Cluster's mass is only 1/10 of the Great Attractor's calculated mass. Like feeling someone pushing you with great force, but turning around to see only a small child. The source of the force is wrong. Wait, there's something more terrifying. 1987, astronomer Brent Tully was mapping the three-dimensional distribution of all galaxies within 500 million light-years around the Milky Way. He discovered an astonishing structure. The Milky Way, Andromeda, Virgo cluster, Great Attractor, Norma cluster, all of them are on the edge of an even larger structure called Laniakea supercluster. Laniakea, Hawaiian for immeasurable heaven. But this heaven scale exceeds all imagination. Diameter, 520 million light-years. Number of galaxies, 100,000. Total mass, 10 to the 17th power suns, equivalent to 100,000 Milky Way galaxies. And the Milky Way's position in this structure is at the very edge of the edge. Imagine the universe as an ocean, galaxies as foam in the sea, superclusters as giant whirlpools. Laniakea is such a whirlpool, 500 million light-years in diameter, 100,000 galaxies rotating inside, dragged by gravity, falling toward the center. And that center is in the direction of the Great Attractor. But in 2014, scientists discovered something even more terrifying. Laniakea itself is also being dragged by something even larger. 2008, astronomer Alexander Kashlinsky discovered a phenomenon he called dark flow. He analyzed distant galaxy clusters' motions and found they're not just receding with cosmic expansion, they're also moving extra in the same direction. Direction: Centaurus. Speed: 1,000 kilometers per second. Range affected: 3 billion light-years. What does this mean? It means somewhere 3 billion light-years away, there's an even larger gravitational source, massive enough to drag all matter within 30 billion light-years. How big is this thing? Scientists calculated its mass is at least 100 times Laniakea's, equivalent to 10 million Milky Way galaxies. But the problem is we can't see it. Not blocked by dust, but because it's too far. Light from there takes 13 billion years to reach Earth. The universe was only 800 million years old then. What we see is what it looked like 13 billion years ago. Where it is now, what it looks like, nobody knows. But its gravity has already crossed 13 billion light-years, dragging us toward some direction, making us fall. 2013, scientists using X-ray telescopes finally saw clearly what's behind the Great Attractor. There's an even larger structure containing 47 galaxy clusters, total mass 2 times 10 to the 16th power suns. Name: Shapley Supercluster. Distance: 650 million light-years. It's the largest mass concentration in the observable universe. All galaxies within 1 billion light-years are falling toward it. The Milky Way 2, Andromeda 2, Virgo Cluster 2, Laniakea Supercluster 2. We're all falling in that direction at 600 kilometers per second. We've been falling for 13 billion years and will continue falling for tens of billions more, until either captured by its gravity completely or cosmic expansion pushes us too far for gravity to hold. But right now, at this moment, we're still falling. Imagine your motion trajectory right now. Earth rotating, equator speed 1,670 kilometers per hour, you're spinning. Earth orbiting Sun, speed 100,000 kilometers per hour, you're circling. Sun orbiting galactic center, speed 820,000 kilometers per hour, you're rotating in a larger circle. Milky Way falling toward Andromeda, speed 400,000 kilometers per hour, you're falling toward our neighbor galaxy. Milky Way and Andromeda together falling toward Virgo Cluster, speed 1.4 million kilometers per hour, you're falling toward larger structure. Entire local group falling toward Great Attractor, speed 2.16 million kilometers per hour, you're falling toward invisible monster. Laniakea falling toward Shapley Supercluster, speed 3.6 million kilometers per hour, you're falling toward the universe's largest mass concentration. And Shapley itself might still be falling toward something even larger, speed unknown, you're falling toward completely unknown direction. Adding all these motions together, your speed right now relative to cosmic microwave background, 2 million kilometers per hour. Faster than 1,000th of light speed. And you're sitting in a chair, scrolling your phone, feeling completely motionless. Scientists calculated the Milky Way's future trajectory. If cosmic expansion maintains current speed, in 3 billion years the Milky Way will collide with Andromeda, merging into a giant elliptical galaxy. In 10 billion years, this merged galaxy will gradually approach other galaxies in Virgo Cluster. But will never reach the Great Attractor. Because cosmic expansion is accelerating, dark energy is tearing space apart. Distant galaxies' recession velocity will exceed gravity's pull. Eventually gravity will lose to cosmic expansion. We'll stop falling, then start receding, further and further away, until Shapley Supercluster disappears beyond the cosmic horizon. But until then, for the next tens of billions of years, we're still falling. toward a place we'll never reach, at 600 kilometers per second, falling. This is the most terrifying thing about the Great Attractor. Not its mass, not its gravity, but that we can't see it. Like standing at a cliff's edge, fog ahead, you know the cliff is there because you hear echoes below, feel the downward pull, but you can't see it. Don't know how deep the cliff is, don't know what's at the bottom, don't know what happens if you fall, only know you're being pulled there and cannot resist. 2016, scientists using South Africa's Meerkat radio telescope array barely penetrated the Milky Way's dust belt, photographed some galaxies in the Great Attractor's direction. They counted, galaxy density in that direction is 3 times surrounding space. Confirmed there really is massive mass concentration there, but what we see is just the tip of the iceberg. Most of the structure still blocked by dust. We can only infer its existence through gravity, like a blind person touching an elephant. You touch the elephant's leg, know there's something huge there, but you'll never see the complete elephant. And this elephant has a mass of 10 quadrillion suns. It's dragging 100,000 galaxies toward some direction, falling. Imagine the universe's hierarchical structure. Smallest level, stellar systems like our solar system with 8 planets, diameter a few light hours. Second level, galaxies like the Milky Way with 400 billion stars, diameter 100,000 light years. Third level, galaxy groups like the Local Group including Milky Way and Andromeda, diameter 10 million light years. Fourth level, galaxy clusters like Virgo with 2,000 galaxies, diameter 100 million light years. Fifth level, superclusters like Laniakea with 100,000 galaxies, diameter 500 million light years. Sixth level, supercluster structures like the gravitational web around Shapley, diameter 1 billion light years. Seventh level, cosmic filament structures like galaxy walls, diameter tens of billions of light years. Eighth level, observable universe, diameter 93 billion light years. And we, at the first level, on a rocky planet orbiting an ordinary star, being pulled by fourth level gravity, falling toward fifth level, destination is sixth level. And the entire sixth level might still be falling toward some node in the seventh level. At this scale, the Milky Way is a grain of sand. The solar system is an atom, Earth is an electron, and you don't even count as a quantum. But you know all this. You're just a quantum on an electron in an atom in a grain of sand, but you know this grain of sand is falling at 600 kilometers per second toward a massive structure 600 million light years away. You know that structure's mass is 20 quadrillion suns, you know it's dragging 100,000 galaxies, you know we'll never see its full form because it's hidden behind dust, because it's too far, because cosmic expansion will push us away. But you know it's there. You used less than 100 years in a 13.8 billion-year-old universe, on a 4.5 billion-year-old planet. You invented the telescope, measured galaxy motions, calculated gravitational equations, mapped the universe, then discovered you're being dragged by the invisible Great Attractor. This discovery took less than 50 years, from first observations in the 1970s to mapping Laniakea in 2014. Humanity used 50 years to understand 500 million light-year scale cosmic structure. And this 500 million light-year structure doesn't even know we exist. Right now, you're still falling at 600 kilometers per second toward the Great Attractor. You can't stop, you can't change direction, you can't even see the destination clearly. Gravity will continue pulling you, pulling Earth, pulling the Sun, pulling the Milky Way, pulling all the stars you can see, toward that invisible monster, falling. Tens of billions of years from now, cosmic expansion will win, will stop falling then start receding. The Great Attractor will disappear beyond the horizon, Shapley supercluster will vanish, Laniakea will disintegrate. Eventually we'll float alone in the void, seeing nothing around us, only the Milky Way left, or by then called the Andromeda Milky Way merged galaxy. Astronomers then, if any exist, will look at the pure black night sky thinking the universe contains only them. Won't know that once there were 100,000 galaxies falling together in the same direction. Won't know there was once something called the Great Attractor that dragged their ancestor galaxies, running for tens of billions of years. All evidence will be erased by cosmic expansion. But right now, January 2026, you know. You know you're falling, you know where the destination is, you know you'll never arrive. And this knowing might be where meaning lies. While being dragged by irresistible force, while falling toward an invisible abyss, while not even counting as dust on the cosmic scale, you can still look up at the sky. Measure velocity, calculate trajectory, map the cosmos, then say, I know where I am, I know where I'm going, though I'll never arrive, though I can't change it, but I know. Maybe this is humanity's greatest rebellion, not fighting gravity, not stopping the fall, but understanding the fall itself while falling. The universe can drag us, but cannot stop us from knowing we're being dragged. And this knowing transforms the 600 km/s fall into a journey. The universe will forget us, but before being forgotten, we saw the starlight, understood gravity, calculated the ending. We existed, and perhaps that's enough.